Here is my solution. We're using the dictionary as our cache. We're going to use A and B as the key to this cache. So I just made a variable here called key, which is just a tuple of A and B. And in Python, you can use a tuple as a key in a hash table. Not all hash tables work this way, but the dictionaries built into Python are really convenient. So the first thing we do is we say if key in cache, and if so, r equals cache key, which basically looks up that value in our cache. If it's not in the cache, we run complex computation. We set cache key to equal r, and then we return r. So let's see how this runs. Okay, so if I were to call cached computation with the inputs 5 and 3, we see the value 8 prints out. Okay, and it paused for half a second, but you'll just have to believe me. Let's add some extra information here so we can see how long it's taking to run. Okay, the first thing I'm going to do is I'm going to store in a variable called start time the current time. If you call time.time using the time library here, this will return the current time in seconds. That's just our starting point. And then we'll actually print our cached computation like we did before. And then I'll print how long it took to compute that. And so all I'm doing here is I say print, and I'm printing the string. The first computation took %f seconds. %f is just like %s, except it's we'll print a number formatted a little bit better. And I'm going to print the current time minus the start time, which will basically give us how many seconds this computation took to run. So let's give this a run. Okay, and we see the first computation took just over half a second. And that makes sense because we sleep for half a second, and otherwise we're just adding two numbers, which doesn't take very long at all. Let's go ahead and run this a second time and see what happens if we run it twice in a row. Okay, so I just copied and pasted these lines, and we're going to run them a second time. So we're going to restart the start time, and then we're going to run the same computation again with different numbers, and we're going to print how long it took to run. So let's give this a run. Okay, so now we see we printed out two things. Printed out the result both times. The first time, the computation took 0.5 seconds, and the second time, when we had a cache hit, when we ran through this piece of code here, the computation took 0.000011 seconds, which is substantially faster. So if we had to run this computation a lot, let's say we were returning the front page of ASCII-Chan and we didn't want to do that database query over and over again, and we cached it, we could get a substantial speed improvement. Now, who knows how long it takes to actually run to the front page of ASCII-Chan. We'll get to that in a little bit. But this is the general algorithm, and you should get familiar with this algorithm because you'll be using it a lot. There's lots of different ways you can cache things, lots of different types of caches and all sorts of things, but the algorithm is always the same. Check to see if something's in the cache. If it is, return it. Otherwise, compute it, store it, return it. So good job if you got that. And let's move along to a real-world example.